You have finally made it to the end, or well, almost the end, but the last section of this unit, which is so very, very exciting. We're finally on the last piece, and if you did very well with arc length, the area of a sector is going to go nice and smooth. It's pretty much the same exact idea. The only difference is we're dealing with area instead of the arc length, and then we're doing out of the area of the circle is pi r squared instead of 2 pi r per circumference. So let's go ahead and get this guy going. So a sector of a circle, kind of think of it like a slice of pizza. It is a region that's bounded by two radii. So you can see here the x, z, y, z, and a arc such as that here. And it's going to be kind of like the same idea that we did before, in the sense of we're going to be doing that out of the area of the whole thing. And we're going to kind of take a look at that, knowing that that's going to be out of 360, the angle measure and everything. So let's get this area of sector theorem written down. So again, very similar, as you can see, to the other one. I decided this time to put the linear units on the left side and degrees on the right side. But again, it doesn't matter. It can be flip-flop because it's an equal sign and it's symmetric. Okay, remember that lovely term from a while ago. Anyways, so in this case, we're talking about area of a sector, which is, in this example here, is this little portion that my mouse is hovering over, out of the area of the whole thing. And remember, it's proportional to the measure of that arc here in terms of degrees at a 360 degrees. So let's go ahead and jump into an example with this. We want to find the area of the sector DPH. So it's this portion right here that's shaded. And we're going to leave our answers in terms of pi. So thinking back to our lovely proportion, this time I'm going to use letter S instead of L because we're talking about the area of a sector. Since the radius is 15 and the area of a circle is pi r squared, I'm going to take 15 and square it. So that's 15 squared is 225 times pi equals, and then over here 72 out of 360 is going to be my guys, everything that's in terms of degrees and everything. Okay, so well, I'm going to go ahead and start cross multiplying. 72 times 225 is 16,200 equals 360s. And so I'm going to divide both sides by 360 and I get 45 pi. Okay, and now this is area. Okay, so we're talking about the whole space in between there. So we're going to use our units squared. Okay, now 72 out of 360, 72 is 1/5 of 360. So if I took 225 and I divided by 5, I'm going to get 45. Okay, so it's proportional just like we talked about with arc length. Let's find other pieces since the process is the same for all the problems. In this case here, we're going to work towards finding the radius of the circle. When I do that, I first probably want to go through and find what the area is and then use that to find the radius. Okay, so in this here, you see I have A equals 39.52 inches. That's talking about this little portion right here that's shaded. And so when I create it, I know that 39.52 is the area of the sector over pi r squared. I don't know what that is, so we're going to have to find out what that portion is, equals 175 over 360. Now, if I was looking for the area of the circle, maybe you want to go ahead and stop and put an A here instead. That way I know I'm looking for area of the circle. But since I'm finding the radius, I can go ahead and put in pi r squared. That way my only variable is going to be the r in there. And so when we're all done with this whole process, I know I'm finished. Okay, so let's go ahead and cross multiply. When I multiply 175, I'm going to go ahead and multiply it by pi. I get 549.5. And 39.52 times 360 gives me this nice number here. And we're going to go ahead and divide. When I divide, I get about 25.89. Now this represents radius squared, so we have to find the radius. So the opposite of squaring something is the square root. So we're going to take the square root of both sides, and I find my radius is about 5.09. Again, that's going to be represented as inches. So if I wanted to do anything else, like find the circumference from here, then I would take my radius and multiply it by 2 pi r. Okay, so we can find a lot of things given some pieces. All right, here's another kind of thing that you need to be familiar with, which is finding the area of the shaded region. We're going to keep our answers in terms of pi, so let's kind of look at this picture. I want to find just this little strip right here around on the outside, and what I notice is I have two circles going on in here. So thinking about it, I realize, okay, well, I want to get the area of the shaded region, so I know I'm going to have to get the area of the whole circle. Well, I need to take away the one that's not shaded, so I'm going to subtract that off. Okay, so this is what it's going to look like. To get the area of the shaded region, I need to find the area of the whole circle, like the big one, and I'm going to subtract the area of the non-shaded portion. So to get the area of the circle altogether, now remember 3.5 isn't the radius, it's the whole length from 9 to 3.5. So it's going to be a total of 12.5. So that's what I'm going to square in pi r squared to get this 156.25. Now the area of the non-shaded portion, well, that's going to be this little piece here with the 9. And so that's just going to be 81 pi. And kind of like with x's, I can add and subtract numbers without doing anything with the pi. So 156.25, I'm going to subtract off 81, and we get about 75.25 pi. So again, this is if I want to keep everything in terms of pi, I can do the exact same process and multiply everything through by pi to get a decimal answer. So instead of 156.25, I'm going to do, sorry, let me multiply that out. I get 490.87, okay? And same thing with the 81 pi. So I can go ahead and get decimal answers that way as well. Doesn't matter. Just read your directions so you know what you need to do. Okay, so let's take a look at this next problem. We want to find the area of the lawn that is covered by the sprinkler. I know there's an exclamation point on there, but that's going to represent a degree. Please don't ask why the picture does not have a degree sign there, okay? So let's go ahead and do that first. What I see is, again, it's a portion out of a circle, and I want to essentially find the area of this. So I'm going to go back to that original proportion that I have in the beginning, which is S over area equals the arc over 360 in terms of degrees. And so it's 135 degrees, so I'm going to put that over 360. The radius is 16, so it's going to be 16 squared pi, and I'm solving for S, or what the area of the sector is. If I go ahead and decimal, I can do decimals with this one if I really wanted to. I don't have to. I didn't indicate it. If you wanted to write it out as 96 pi, or if you want to write it out as 301.6, it doesn't really matter. But all in all, we're covering about 96 pi feet squared, or 301.6 feet squared. Either answer is fine. Why don't you go ahead and hit the pause button and try this second one here, where I'm changing the radius now, so the water pressure only reaches 10 feet. Go ahead and hit pause and do that. All right, let's see how you did. So this would be my setup. The only thing that's changing is this 16 squared is changing to a 10 squared. And when I cross multiply, I get 75 pi over 2. If you had gone through and divided that and got 37.5 pi, then that's fine too. Probably would take in the either answer, okay? All right, how about you try this problem all on your own? Make sure you're keeping your answers in terms of pi. All right, let's see how you did. So the first thing I know I need to do is find what this whole pizza slice is. I can see that the radius is going to be 6 meters altogether. So I'm going to find what that is. So 45 out of 360 equals the sector out of pi r squared, or pi 6 squared, so 36 pi. So cross multiplying here, I end up with 9 pi over 2, and that's going to give you the area of the whole thing with the shaded and unshaded piece. And so now we're going to have to go through and find this little unshaded piece. So we're going to use the smaller circle for that one. So I'm going to do S over pi 3 squared equals 45 over 360, and I end with 9 pi over 8. Okay, so that's this little portion right here. Okay, it's not just getting cut in half, so keep that in mind. All right, so then from there, I'm going to find the area of that shaded region, keeping it in terms of pi. So what I'm going to do is take that 9 pi over 2, and I'm going to subtract 9 pi over 8. So I would convert the 9 pi over 2 so that I can get an 8, which means multiplying top and bottom by 4. So I have 36 over 8. And I can do 36 minus 9, and I get 27 pi over 8. And that would be your answer there. Hopefully I didn't go through this too fast for you. Excuse me. Let your teacher know if you have any questions. Like I said, it's very similar to arc length. The only difference is we're dealing with area now, so we need to use pi r squared. Go ahead and get started on the practice.